Well, so he's asking if you're, is that why it's hard to ski in a whiteout or at night when there's no light, ride your bike? Well, balance, it's tangentially related to that. Balance depends on three things. Equilibrium depends on three things. Feedback from the muscles and joints, feedback from the inner ear, these patterns here, and feedback from the vision. So when you lose the vision, you're only relying on two of the three. Now, most people can rely on two of the three and get along okay, but if you take away the vision and one of those other two, the proprioception or the semicircular canals, aren't firing as well as they should, then you'll end up with a problem with your equilibrium. And that's why we do the Romberg test and close the eyes, because you've got the semicircular canals, or actually in the static position, you've got the more the saccules and utricles firing without, the semicircular canals fire when you move. The other inner ear organs, the saccule and the utricles, they're pretty much static organs for the most part, but the utricles in particular are the ones that we use with the tonic labyrinthine reflexes. Those are the ones that are activated. They don't fire when you move, they just fire where you are. They tell you where your head is in space. They don't tell you if you're moving. The semicircular canals, they tell you if you're moving. So the tonic labyrinthine reflexes are tonic. They tell you about the position of the head. So they're firing now, they're firing now, they're firing now, but they don't fire from position to position as such. The semicircular canals measure acceleration, deceleration, or movement of the head relative to gravity. So when we do the Romberg test, it's really a cerebellar test primarily. We close the eyes, we take away one of those three things. And that tells us that there's a problem with proprioception or a problem with the inner ear. And that's...
C-sec, that would be more semicircular canal.
What would be what?
C-sec, if you're under, if you're in a boat, you're just inside, you get seasick, but if you go outside and look around, you fix your eyes and that would neutralize it.
Right, exactly. It's the same as seasickness. If you're getting on a boat and you're getting seasick from moving all around, you're firing those semicircular canals, you go outside and you focus on a point, it'll take away the seasickness. The seasickness is because of the asymmetrical firing into the brainstem, into the pontomedullary reticular formation, which is where the vital centers are, which is the vagus nerve is, which sends down parasympathetic activity, which makes you nauseous and dizzy from the semicircular canals. You get dizzy, but you get the nausea from the vagus firing. And so that's the same as spinning around a circle. But so when you're on a boat, if you don't get sick, you eventually adapt to that boat movement. And the way you adapt to that boat movement, we talked about this before in other classes, is your muscle spindle cell gain is turned down so that every time your muscle spindle cells fires, they don't jerk you back this way or this way. Every time the boat moves, you don't jerk all around. So your muscle spindle cells are set at a lower setting, so you don't fire so readily. This is a central phenomenon, really from the cerebellum. And then what happens is there's a cerebellar loop that forms that dampens your muscle spindle cell activity, and you move around on your boat and everything, and as the boat moves, you don't even notice it, but you're walking around and you're not flipping off the edge of the boat. You get on land, I feel like I'm still on the boat. Why? Because those pathways are still dampened. It takes a while for them to get back to normal, and you feel like you're on a boat for 10 minutes or an hour or whatever it is later. Because you have to get back now to dampening that cerebellar down pathway, vestibulospinal pathway, which is part of a loop of adaptation with the cortex. And so that's how you can manage the feeling of getting off the boat. It takes a little while, on different people. And some people have a real hard time getting over it. And that means they have a cerebellar problem. Yes?